All right, welcome back. Now we are quickly looking at amides, okay? And here I want to show you or introduce you to the two brothers that we have in chemistry. Real brothers. They don't look alike. They're not twins. They don't have much in common, but they're real brothers, okay? So let me show you. And these two brothers are amides and esters, okay? Now, first thing which you want to know is how do you see an amide? An amide is going to have some carbons here. Remember, R representing carbons. Then you have a double bond O bonded to an N, which will now have your more carbons like this, okay? And this, we'll be calling it an amide. Then, for an amine, we could have it, okay? It's just, so this part is the one which we want, okay? It could be now hydrogens. It could be hydrogens, okay? But the part which we want is the C double bond O then bonded to an N. For amines, it would be R bonded to C, which is bonded to hydrogens, then bonded to a nitrogen. Okay, so this is actually hydrogens. There is no double bond to oxygen. Then it's bonded to a nitrogen. So this makes it an amine. Amide has a C double bond O. Great. Now, what we say, we've done it again. Now, amides are friends or brothers to esters. Now, let's see what it is. What it is that we say they're brothers. Okay, first is, how do we make these amides? The preparation, the amides preparation, they are made by adding ammonia to either an ester, which we've seen, ammonolysis, okay, which is adding ammonia, NH3, either to an ester or a carboxylic acid. So here it is. If we have this time I'll put a carboxylic acid, okay, something like this, double bond O, then OH. This is a carboxylic acid, okay, because our last carbon is this one. And we have it like this, bonded to a double bond O and then an OH. If I add ammonia to this guy, okay, if I am to add ammonia to this guy, let me put it, we can just have it over an arrow like this. If you add ammonia, the only time we've seen this guy ammonia, it is in this ammonolysis thing. When we add ammonia, we must get an amide. So what's going to happen? We need this C double bond O, but here is where our N is coming. So it's going to be something like this. Here is now N, and we could have it as an H2 or whatever. Since there is no other carbons, it's an N here. Then we have our double bond O. That's an amide, okay? And what are we going to release in this case? We are going to release water, okay, in this ammonolysis. And again, the ammonolysis of esters, which is what I left just above here. Look at it. We have an ester. We have ammonium. Remember what's going to happen? This guy has to go. And we'll put our amide, okay, our double bond, then our amide. And in here, we'll get an alcohol because esters always release alcohol. This R prime goes with the alcohol. So don't forget that. So here we have our amide. And here we've seen another way of making an amide, okay? From this time, what is this guy? It is a carboxylic acid, okay? And if we are to give it the name, it is propanoic acid, okay? 1-propanoic acid. Okay, propanoic acid, great. And we don't have to put this one. We can just, it's going to be propanoic because the carboxylic acid is always on the first carbon. So here we have our amide, okay, and we can call it propane amide. So propanamide, propanamide. Okay, and that's your water, right? Okay, now the next thing is you say to me, okay, bro, we've seen that, we've seen that this guy comes from esters and carboxylic acid, but is that what makes him brothers? No. What makes them brothers is that the reactions of amides is the same as the reactions of esters, okay? The last two, which is the hydrolysis, okay? In esters, we did them as the first two, okay? First is the hydrolysis where you put water, but you need an acid, so we call it acid hydrolysis, okay? Acid hydrolysis, we actually use water, but we add an acid in there. Hydrolysis. Okay, hydrolysis. Okay, and what happens is, let's start. So here we have our amide. Okay, could be the bonded to an N. Now this time we'll make it bond to carbons. Okay, there we go. So here we'll put it as R prime. You'll put it as R prime prime. Then it's going to add to water, but this water is going to be acidified. So here we are actually specifying that the acid is HCl in this guy. Then what do we get? What do we get? We are hydrolyzing. So what you should know is that for amides, they break right here. Okay, we saw that for esters, they only break on the OR prime. Is the R prime that goes, leaving the O behind. Okay, but in here, they actually break right here. So what we will end up having is R bonded to C, double bond O, and in here we will now have an OH. Okay, so we actually would write it as R now, and then here would say OH. Okay, then plus this N comes and goes away. It's an N bonded to an R prime and an R prime prime and an R prime prime. You say, oh, 2 bonds already. We just need 1 more. Let's just put hydrogen. No, for this time, we are going to do this. We'll put 2 hydrogens, okay, and it becomes a positive guy, and then you have a chlorine minus coming. So this is now going to be what we call an alkyl ammonium salt, okay? What's going to happen is we have chlorine coming, we have the 2 hydrogens, okay, that are left because it was, we have it like this, we have the H2O, the hydrogens here, anyway, which is going to come. So what we end up having is the Cl minus and 2 hydrogens to make it plus. If there was 1 hydrogen, then we would not need this. So this is R prime prime. That's what we have. And in here, it breaks, it becomes an OH. That's acid hydrolysis. Now, what about base? Let's talk about base hydrolysis. Okay. Base hydrolysis, what are we just going to add? We just add our base. So it's going to be the same guy, double bond O, and then here we have an N bonded to an R prime and an R prime prime. We are adding a base. Now, the same thing, what you must remember, the same thing is that this guy breaks right here, okay? The bond between N and C. So what are we going to end up having? We will have, in the end, your R bonded to C double bond O. So this time, it's going to be R, C double bond O. Then in here, we are going to have an O minus and Na plus, this Na, okay? And then what are we going to have as the other thing? This N comes away, but he's going to behave himself this time. R prime prime is just going to have an H, which is going to be enough. So this is now an amine. Okay, because an amine, we know that in an amine, it is just bonded. It is when you have your nitrogen just bonded to a carbon. Okay, just bonded to a carbon with no double bond O. No double bond O. So that's an amine. And in here, you say, what is this? This here is a carboxylate salt. It's a salt. So it's a salt, which we would say it would call sodium something OH. Okay. In here, this one is just a carboxylic acid. Okay. Carboxylic acid. That is what we have in here, which is the same, similar products to what we had, same products when we were doing it for esters. But just that for esters, they break on different positions, but it's the very same thing. So for esters, we would just add our H2O and would show H plus on top of the arrow. It's still showing that we need an acid and we'll still get this too. So that's why they are brothers, because they have the same reactions. And these are the 2 reactions and you're done. They're the same as the first 2 reactions of esters. Okay, that's it. Bye.